Welcome everyone to today's stream. Today we're going to go through libraries with Dune. So under Learn Language section in the ocaml.org docs page, we have gone through a lot of the material here. We covered functors previously. Today I want to finish up with libraries with Dune, and then we will finish off with the remaining data structures, right? And then I want to start doing some Dreamweb framework streaming as well. So let's start with this session. So Dune provides several means to arrange modules into libraries. So we will look into Dune's mechanisms for structuring projects with libraries that contain modules. Okay, so we've already gone through modules and functors. So let's go through this minimal example here. We've already gone through your first OCaml program, which used Dune init project. But now let's create this mixtli folder, and in this directory we are creating the project files Dune-project, Dune, cloud.ml and wmo.ml. So let's do that. So Dune project will have lang Dune 3.7, and then package will be wmo clouds. This is a global project configuration. It's kept to the minimum, including the lang Dune stanza. So right now I am on OCaml 5.1.1 switch. Okay. Let's create the Dune file. So we're going to have a executable name cloud, public name is new. Okay. So each folder requires some sort of build. It must contain a Dune file. The executable stanza means that the executable will be built. Okay. The name cloud stanza means the file cloud.ml contains the executable, and the public name new stanza means the executable is made available using the name new. Let's create the WMO and cloud.ml files. So we have module status is struct let nimbo status ns, and we have module cumulus is struct let nimbus is cumulo nimbus cd n. So in two different modules we are using the same name nimbus here, right? Let's create cloud.ml. So wmo dot status dot nimbus, just to print end line, wmo dot cumulus dot nimbus print end line. So let's try to compile and run this. Opam exec Dune exec noob. So it compiles and it prints the two strings. Now let's look at the tree structure here. So we have apart from these project files, we also have a _build directory, right? So this contains the default folder files and also the executable here, right? Now we can add these _build as part of .git ignore if we are actually going to use Git for doing revision control of the project. Okay. So each .ml file defines a module. In this mixed TLI project, the file cloud.ml defines a cloud module, and the file wmo.ml defines the WMO module that contains two submodules, status and cumulus. So in this context, mixed TLI is the project's name, cloud.ml is the source file, right, which is referred to in the Dune file, right. Noob is the executable command's name, which is what we are actually running. Cloud with a capital C is the name of the module that is associated with the file cloud.ml. Similarly, we have WMO with a capital W is the name of the module which is associated with the file WMO.ml. And WMO-cloud is the name of the package that is built by the project. Now, we can also do Dune describe, which will give the project's module structure. Right. Now, in OCaml, a library is a collection of modules. When Dune builds a library, it wraps the bundled modules into a module. So this way you can have several modules with the same name inside different libraries in the same project. So this is known as namespaces for module names. This is similar to what a module does for definitions by avoiding name clashes. So Dune creates libraries from folders. So let's do an example. So let's in this project, let's create a lib folder. Right? We'll create a libdune file which has library name WMO. We can create a libcumulus.mli file which says Nimbus is a string. We could create the source file, let Nimbus is equal to O Nimbus CB. Then we create status.mli file, and then we actually create the source file, let Nimbus Nimbo status ns. Right. So in this example here, we have all the source modules are found in the lib folder, bundled into the WMO module. To avoid redundancy, we are going to remove this wmo.ml file in the top level directory. Okay. We are then going to update the Dune file, building the executable to use this new library as a dependency. This is how you would actually create libraries in a project. The executable name cloud, public name noob, and then we use libraries WMO. Okay. So Dune creates a module WMO from the contents of the folder lib that we just created. The folder's name here lib is irrelevant. The library name appears uncapitalized in the Dune files, so both in definition lib.dune and used as a dependency in Dune as well. So let's try to run this again. We have to build it. It compiles and executes as cleanly as we expect it to do. Right. Good. Now, by default, when Dune bundles modules into a library, they are automatically wrapped into a module. It is possible to manually write the wrapper file also. This wrapper file must also have the same name as the library. So let's create a wrapper file here for the WMO library. So we can do nano lib wmo.ml. We can say module cumulus is cumulus and module status is status. So on the left hand side, module cumulus means module WMO contains the submodule named cumulus. Similarly, on the right hand side, cumulus refers to the module defined in lib/cumulus.ml file. Again, we run Dune exec and you should get the same output. And we expect the same results. Now, when a library folder contains a wrapper module, as in the case here wmo.ml, is the only thing that one is exposed. All the other file-based modules from that folder do not appear in the wrapper module, are hence private. So using a wrapper file makes several things possible. You can have a different public and internal names. So you can say module cumulus cloud as mapping to cumulus module internally. You can define values in the wrapper module using let construct. You can expose modules resulting from a functor application. We've already seen functors in the previous session, so you can do this. You can apply the same interface type to several modules without duplicating files. And you can also hide modules by not listing them. Now, by default, Dune builds the library from the modules found in the same folder as the Dune file, but it doesn't look into subfolders, right? So in our case here, we have the Dune file and the lib folder here. So let's try to change this behavior. So we are going to create subdirectories and move the files there. Okay. This is what we're going to do here. So we already have lib here. So what I'm going to do is create lib cumulus and lib status. Then I'm going to move lib cumulus.ml to lib cumulus.m.ml. Similarly, I'm going to move lib cumulus.mli interface to lib cumulus m.mli file. Okay. And then we can move lib status.ml to lib status m.ml. I'm using the same name m.ml in both the folders, right? And then we do move the interface file to MLI file. Now, in order to, let's look at lib here, right? So in order to facilitate this change of behavior, we have to use the include subdirectory stanza. Right. So in lib Dune, I'm going to say include subdirectories qualified, and library name is still WMO. You also have to update the library wrapper to expose the modules from the subdirectories, right? So we have to say nano cumulus dot m and status dot m, right? Of course, let's rerun this, make sure everything looks good and the output is the same, right? So Dune exec has the same behavior of the program as we have seen in the previous two examples. Note that the include subdirectories qualified stanza works recursively except on folders that contain a Dune file. Okay. So, the OCaml module system allows organizing a project in many ways, and Dune provides several means to arrange modules into libraries. Okay. So, this ends today's session. It was a very short session. I would recommend you try these examples on your system and see how to organize these libraries and use it with Dune. I'll see you in the next stream.